Okay, so in this video, we're looking at section or topic 5, section 4, logarithms, day 2. So in this problem, or in this notes, we're going to be writing inverses and finding solutions to equations that involve the common logarithm and the natural logarithm, because those are things that we can kind of use on our calculator. So remember that when we're finding the inverse of something, it's usually a couple steps in terms of the process, in which the first step is that we want to switch the locations of x and y. Normally what we're doing is we're then solving for y depending on what our equation looks like. And so since we're going to be looking at logarithms and exponential equations specifically, that second step, instead of solving for y, becomes that we change it to the form, the other form. So if I have an exponential equation that is y equals 8 to the x power, then I want to start by switching the locations of x and y. So that means that I'm changing the equation to x equals 8 to the y power. And then from there, I'm going to change it to logarithm form. So remember that to change it to logarithm form, I'm starting with the base and I'm going that direction. So that means that I'm going to have log base 8 of x, and then that's going to be equal to the exponent, which in this case is y. So log base 8 of x equals y. So that means that the inverse of y equals 8 to the x power is y equals log base 8 of x. Okay, so pretty straightforward. We just switch x and y, and then we switch the form from this exponential form to logarithmic form, and that will solve for y. Later on in the unit, we'll look at more complicated expressions or equations so that they take a little bit extra steps. So we'll add like a solving step at the end. But for now, understanding that relationship is part of just the definition of a logarithm. For example 5, we're going to do 3 different parts, and we're actually going to do each part twice because I'm going to show you 2 different methods. So when I'm solving an exponential or a log equation, so I have 2 exponentials. A has a base of 10, so I have 25 is equal to 10 to the x minus 1 power. B is a natural log equation, so ln of 2x plus 3 is equal to 4. And then the last one is another exponential equation with the base e. And so 2 times base e raised to the 3x power is equal to 7. And so ultimately, if I think about these, I'm going to have decimal answers because like 10 squared is 100, right? And 10 to the first power is 25. It's 10. And so I know that 25 is between 10 and 100, somewhere a little closer to 10. And so I can kind of use that to estimate what the answer is going to be. So I know that the exponent here needs to be like 1 point something. So my answer for x should be 2 point something. So then what we're going to do is work through 2 different methods. The first method is going to involve taking the log of both sides. So taking the log of something works because of the inverse relationship between logs and exponents. So I'm using the property of log base b of b to the x power is actually equivalent to x because this piece cancels. So the fact that this b is the same, that cancels the log and the base of the exponent. So I'm going to rewrite that problem again. So I have 25 equals 10 to the x minus 1 power, and I'm going to leave myself some space to take the log of both sides. So I'm going to do log base 10 because that's the base that I have here. And again, I'm doing that because this 10 and this 10 with the log cancel. So I'm left with just x minus 1 over here. And then on the left side, remember that this is the common log, so I can just write that as log of 25. That means that I can drop that 10. And so now to solve for x, I'm going to have to add 1 to both sides, but what I need to figure out is what is log of 25. So remember that when I'm doing this, so I'm going to take 25, and then this is the common log, so I'm using the log button. This is telling me to the nearest 10,000th. Remember, that means 4 decimal places. And so when I look at this number, I have 1.3979. That 4 is going to leave that 9 there. So 1.3979 is equal to x minus 1. And so that means that to solve for x, what I would have to do then is move the 1 over. So if I add 1 to both sides, I have 1.3979, and I'm adding 1, so that's going to be 2.3979. So that's an estimation of the value of x. Okay, so that's using the first method, which is to take the log of both sides to isolate the exponent, using that property that log base b of b to the x power is equal to x. The next method is where we are just going to use the idea of switching from exponential to log form to solve. So I'm going to rewrite the problem. So 25 equals 10 to the x minus 1 power. So rather than taking the log of both sides, I'm going to switch from exponential form to log form. So my base is 10. So I'm going to switch this to have that log base 10 of 25 is equal to x minus 1. So log base 10 of 25, remember that that's a value that I can find in my calculator, which we already did. So that's the common log of 25. So we have the 1.3979. So remember this, I can ignore that 10 because it's the common log. So I get 1.3979 is equal to x minus 1. And then the same step happens here where I have to add 1 to both sides to isolate, which means that x is still 2.3979. So I should be getting the same answer for these problems because, again, I'm just changing the method, not the problem. Okay, so it's your choice which method you use when you're doing your work. I'm just going to show you both for each problem. Okay, so on the back page, we've got ln of 2x plus 3 equals 4. So the opposite of taking the log of both sides is to exponentiate both sides, which means like I'm going to raise it up to a power. And so since I have an ln, the base of that is e. And so this works in the same way that if I have e to the ln of something, that's equal to just that something. So log base b with a base of b is going to cancel and just become that x. So what this means is that for this problem, I'm going to take, so ln means it has a base of e, so I'm going to do e as my base on both sides, and the equation that I have is my exponents now. So I have e to the ln of 2x plus 3 is equal to e to the 4th power. So again, the point of this is that this cancels, so e raised to the ln cancels, and I just get 2x plus 3. And then I have to calculate e to the 4th power. So if I look at that value, I have e, and then for this, I'm going to hit this button. So e raised to the 4th power is 54.5981, and that's going to round up to a 2. So 54.5982 is going to be our decimal. And so if I want to solve this for x, I've got a couple things that I need to do. I need to get rid of the 3. So if I subtract 3 from both sides, that's going to give me that 2x is oh, sorry, that was 54. I was looking at the next step, right? This was 54. Sorry about that. And then when I subtract 3, I get 51.5982. And so then to solve for x now, I would have to divide both sides by that 2. So if I divide both sides by 2, that gives us that x is about 25.7991. So for this one, because now I have a log equation, I'm doing the opposite. And in that case, I exponentiated both sides. So I raised them up from the base of the log. So if I look at method 2, which is the same as the method 2 on the other one, I'm going to switch forms. So I'm going to rewrite my problem. I'm going to put a line because this one's a little bit kind of close. So I'm going to rewrite my problem. I have ln of 2x plus 3 is equal to 4. So if I want to switch this to exponential form, remember that ln has a base of e. So since ln ignores the e, I have to add it there to help myself. So that means I have e to the 4th power is equal to that 2x plus 3. Okay, so I'm switching it to exponential form. E to the 4th power is equal to 2x plus 3. Remember that we calculated e to the 4th power, so I did e, raised it to an exponent to the 4th power. On your calculator, you might need that caret button, is how you do an exponent normally. So 54.5982. Is an approximation for 2x plus 3. And then notice that that is what I had here. So my steps are going to follow the same. So I have to subtract the 3 from both sides. When I subtract 3 from 54 in that decimal, that's going to become 51.5982. And then now I just have a 2x. And then when I divide that by 2, again, I'm going to get that same answer. Of that x is approximately 25.7991. Okay, so again, I don't expect you to do both methods on your assignment. I expect you to choose one and to stick to that method the whole time so that you master that method. I will always show you both, and then if you need help with the homework assignment, you should tell me which method you're choosing to use so that I can address it in that manner. Okay, the last one, we have something that isn't just an exponent equal to a number or a log equal to a number. It actually has something in front of the exponent. So what we have to do for this problem is start by isolating e to the 3x. And so since there's a 2 being multiplied in front, that would mean that we need to divide both sides by 2. And so that's going to give us the equation e to the 3x power is equal to 3.5. Sorry. I'm going to write this here because we're going to need this for method 2. Okay, so that means that this equation is what I'm going to be able to choose my methods from. So no matter which method I'm using, my first step had to be to divide by 2 so that I have just e to the x over here. If there was something being added, I would have to subtract it. If there was something being subtracted, I would have to add it before I do that division too. So it works the same way as if that was like 2x plus 3, right? I would have to subtract 3, then divide by 2. So now from here, I can choose my method. The first method, because this is a base e, is that I can take the ln of both sides. So if I rewrite my e to the 3x equals 3.5, and giving myself some room to take the ln of both sides. So I'd be doing ln of e to the 3x equals ln of 5. Remember that because the natural log is an imaginary base e, that's what cancels here. So that gives me just 3x, just the exponent. And then I want to evaluate ln of 3.5 in my calculator. So if I do 3.5 and take the ln of that number, again, if your calculator allows you to type, you should type it in the other order so it appears on the screen and on the board. So ln first, then 3.5. So that gives us a 1.252, that 7 is going to round to an 8. 1.2528, which is equal to 3x. And so to get x by itself, I have to then divide both sides by 3. And so that's going to give me an estimation for this x value as, if I divide that, 0.4176. So the value for x is about 0.4176. Okay, so again, that's taking the ln of both sides so that I can cancel out the base e. The other way to cancel out the base e is to just rewrite it into ln form. So after our first step, we had e to the 3x equals 3.5. So I'm going to switch to my log form. Since the log here is a base e, I'm technically doing log base e of 3.5. And that is equal to 3x. Remember that log base e is ln. That is the natural log. So ln of 3.5 is equal to 3x. Again, we calculated that ln of 3.5 is 1.25228. And that's an approximation of 3x. So then dividing both sides by 3 gave us an approximation for x as 0.4176. Okay, so when you're doing this assignment, it will tell you which example to look at in your textbook. And so then you're looking at the just picking one method and using that method to solve. So you don't need to know both methods, just decide which one you like the best and use that continuously through your work.